All right, guys, here's what we're going to do. I'm just going to talk to you like I do regularly because I am right now. um, so these 6 questions that I passed out to you, we're going to go over these. These are very reminiscent to questions that you can expect to see on the Unit 1 test for descriptive statistics. All right, so the first thing with this first question that you see up on the board here, a lot of people get thrown off by this with the box plot. Okay, it's tilted a little bit different. Now, you probably won't be able to see this on the video, but I'm going to have you label this. It's kind of tilted on a different axis here. This is your lowest value. Now, if you want to label this part, I would label it. Okay, that is the lowest value, and hopefully this works on my end. Okay, I'm going to trace that. So here is my lowest value. Okay. So we're looking, basically, you got to know how to read this box plot because it is weird. Okay. The next part, okay, right there, that is Q1. Okay. Label the pieces of the box plot before we even dig into any of the questions. Because every year they have a set of box plots. And they're going to have you compare those box plots. And the question will say which one is true. If you can label the parts of the box plot and read it and give estimates, okay, you should be okay and prepared on that question. Okay, that's the main thing. Okay, I'll change up the color. Let's go purple. The line in the middle, that's your median. So label that. Don't be afraid to write on the test. Okay. You know, label what you're reading. Okay. In orange, we got Q3. Let's go blue. We got the highest value right here. Actually, take that back. The highest value is this guy right here. Okay. What did this box plot, and you guys can answer it, it's on recording, whatever, who cares. Okay. The highest value, what does that highest value happen to be in this case? It is an outlier. Okay. Major purpose of a box plot: to identify if there are outliers. I promise you, you need to know. You're going to need to know that. And there's going to be another thing you need to know. There's 2 major purposes. One identifies outliers. The other one identifies distribution of data, distribution shape. Okay? So label that. All right? Label. Okay, now I'm going to get back to the original screen here. That way I can scroll down. And we'll look at the questions here. Okay? It's easy, okay? I can't wait for you to comment on that. I'm not going to let you. What is being measured in this box plot? Now, if you read through the information, it might ask that type of question. Okay? I got questions A, B, C, D, and E. Okay, I put those type of questions because I've seen those type of questions on these unit tests. They want you to be able to read through the box plot. A big question is, well, what is being measured in the box plot? Read through the passage. Okay, the passage talks about the Michigan Department of Transportation, aka MDOT, intends to repave 80% of its highways. That 80% has no bearing on our data in this question. Contractors are currently bidding on the project. To help make a decision about which contractor to hire, MDOT asked the contractors to estimate the number of work days required to finish the job. 20 contractors. Okay, now let's think about 20 contractors. That's going to be our what? Sample size. Okay? So on your paper out to the side somewhere, put N equals 20. That's your sample size. They bid on the next job, which is, the repaving the highways. The box plot represents their estimates of the number of work days required to complete the job. So know what that data represents. That's our variable of interest. Okay, there's some vocabulary there. Variable of interest. Okay, so question A, what is being measured? Okay, I'm going to simply write the contractors. Hopefully it would write for me. There we go. It's the contractors' estimate of work days. Okay. Okay, that's sloppy handwriting, but you know how I write. Know what that represents. Know what your plot histogram is representing. Okay? What kind of data is this going to be? That's something else you need to think about. Being able to distinguish. Well, what does quantitative data look like? What does categorical data look like? If I'm MDOT and I look at these contractors, think about the question they're going to ask. Once you think of that question that they're going to ask, think about the types of responses that you'll get. Okay? If I'm MDOT and I say, hey, Sam, how long is it going to take to complete this job? They're not going to answer yes or bet. Okay? They're going to say a number of days. It's going to be a numerical response. That means it's numerical quantitative data. Okay? That's why we use a box plot. Know what kinds of graphs that we can create for quantitative data. There's two of them. Box plot. What's the other one? Starts with an H. Histogram. Okay? Quantitative histogram. Box plot. Okay? Now question B. Let me get out of this mode here. Question B. Ask, are there any outliers? If so, approximate the value. Okay, we have clearly one. Okay, it is located. I'm going to put a box around it. Right there. There's your outlier. Okay, now try to estimate that. Pay attention to the scale. I can't reach up this high. Okay, that would be approximately what? 900 days. Ooh, it's like the bypass here in Portsmouth. So that estimate is going to be 900 days. So that's a little over what? Almost 3 years, 2.5, 3 years, something like that. Wow. Now, if that's an outlier and that's the extreme, that's the highest value, something else we need to think about. The odds of them getting a job are going to be what? Pretty slim. Slim to none. Okay? So that's why we would create a box plot. Well, what's the outliers? We need to kick those out. Because you know what? That extreme high value is not going to work for us. Okay? Now, if that was an extreme low value as an outlier, guess what? They're probably getting hired. Okay? So you have to be able to look at the situation there. All right. Next question. Approximately, what are the values for the 5-number summary? Okay. Now recall what the 5-number summary is. Okay. The 5-number summary, you need to know this. You need the lowest. You need the highest value. You need the Q1, you need the median, and you need Q3. Those are the 5 parts. That is the 5-number summary. That can be found in the box plot itself. Okay? So when I look back, that stuff that we labeled earlier, you're going to have to write those down. Okay? So we'll do that, looking at that. And I'll just write it from here. What is my lowest value approximately? Okay. Careful. Okay, it's right here. Okay, here's 100. If you said 40, you're in good shape. Okay, I want you to think on that. I know. I wanted you to think on it because you got to pay attention to the scale. I wanted you to be sure. Okay. Q1, approximately, what would that be? 95. Yeah, 95, 99. Somewhere close. I wouldn't say 100 because that would have to be right on the mark. But it's somewhere close. Okay, median, what would you estimate that to be?
150.
Yeah, 150, that's a good estimate. If you said 145 or 155, I mean, come on, it's close. Okay, you're making good approximations. So far, let's keep it going. Q3. 375, 380, I like it. Okay, not quite 400. Okay, highest value. Be careful what you say. Okay, highest value is right here. I know it's an outlier, but it's there. Okay, it's part of the data. That is our 5-number summary. Okay, is that okay? All right, I'm going to get out of this mode here. And, okay, next question. Approximately what is the value of the IQR? Well, from your approximations that we said in part C, what was the Q3 that you came up with? I'm sorry, what was that? 380. Okay, so we'll write 380. And we'll subtract that from, you said what, 95, something like that, Q1. So, there's our Q1. So 380 minus 95, it gives you what? 285, that is our IQR. Okay. Well, it's kind of interesting to see that, actually. You know, when 50% of your data is between 95 and 380 days, it's a big spread. Okay, and then go back to the sample size. Okay, go back to the sample size. That's just out of 20 contractors. Okay, you might want to write this down. You may not need it now, but you're definitely going to need it later. A sample size of 35 or greater is ideal. And we'll talk about that later. Some say 30 and 32. I'm going to say the magic number is 35. 35 is a good sample size of data for quantitative data. Okay? For quantitative data, 35 is a good sample size. Okay, now part E, it might give you a question about the box plot. Okay, now I want you to think about this. Okay, usually when we look at part E, says something about, you know, how would you classify the shape of the distribution? Explain. Okay. The major purpose of a histogram is to describe the shape. Okay, now but I want you to think about something. you have an outlier, it's to the right. Okay? What does that mean about the mean compared to the median? It's going to chase the outlier. It's going to be greater than the median, remember? Okay? Now, if you have an outlier to the right, let's think about this curve that we would have if we were to draw a histogram of this data. Most of the data is here, but then it starts to skew to what direction? Right.
It's basically just flip it side.
Yeah, exactly. Okay? It's skewed right. This suggests that our mean is greater than the median. See, you guys are thinking like statisticians. That just sends chills. I got goosebumps just think about it. Okay? It means our mean is greater than the median. Okay? I heard this. Mean chases outliers. Okay? And since our outlier was so much greater than everything else, okay, that plays a big factor. All right? Remember, the box plot that you might see, and I've seen it, you might see them drawn out regularly like you would on the calculator when you create them, or they might flip it like that. Okay? So, keep this for review, and you'll have this video for review as well. Okay? All right, let's push on to questions. Question 2. I'm going to try to zoom out here as much as I can. Okay? Probably just going to get through question 2 today and be done. So that'll be part 1 of the video. So question 2, a consumer agency is testing appliances for a series of articles in their magazine. Currently, they are working with cooktops and ranges. Oh boy. They have selected 16 of the most commonly used models. Now, think like a statistician. What's their sample size? 16. N equals 16. Good. Using a series of tests, the agency will estimate the lifetime of these models. Now, I'm sure you've heard these old timers. Well, back in my day, they made things pretty solid. Now anymore, they just break and blah, blah, blah. It might be true. That'd be something that could be tested by a statistician. Okay, so here's our histogram. This is lifetime. Now, this is a lifetime in months. Okay? Now think about our sample size. I might get faint here. Think about our sample size. We should have 16. Here's 1 plus 3, that's 4. Plus 5, that's 9. Plus 3 is 12. Plus 2 is 14, right? Plus 1 is 15. Plus 1 is 16. What happened in there, Mr. Seidel? There's not part of the histogram. Okay? Remember like yesterday when you guys were making the pie chart and the bar chart and you're like, what happened to musical? Guys, I'll be honest, in that study when we were looking at 186 rated R films, how many of those rated R films are really going to be musicals? Here's Jason dancing along. Hey, I'm getting ready. It's not going to happen. I'd like to see it happen just for a good laugh. Then be a comedy. Okay? So, there's nothing in between this timeline here. Now, pay attention right through here. This is the lifetime in months. So, we only had one appliance survive between 100 and 125 months. Now, that's pretty good. I mean, there's 12 months in a year. Times that by 10 years, there's 120 months. You get 10 years out of anything anymore, that's pretty good. Okay? Depends on how much you cook and stuff, I guess. I I slaved beside a hot microwave with pizza rolls, so I guess it don't matter. Okay, so question A, what is being measured in this histogram? Lifetime of appliances in months. And that's numerical. You know, if you're conducting a study and you're a survey, whatever, how long did this last you? And this is, 16 popular models here. You know, you kind of have to expect it's going to be a numerical response. That is quantitative. So question A, lifetime in months of the appliance. And these are just all the different types of questions that we could see on the unit test about a histogram. Approximately, here we are, part B, approximately how many cooktops and ranges had a lifetime between 150 and 175 months? Read it. Okay. You should see that is 5. Okay. This test could be really simple, and it should be. I apologize for the bell. But it should be pretty simple. You just got to learn to read it. So, question B, we're looking about 5 appliances. Okay. Part C, stop me if you have any questions. Part C, approximately, okay, this is a good one. Approximately what percentage? Okay, pay attention to little words like that. If they ask for a percentage, you better give them a percentage. And you got to be careful of that. Of cooktops and ranges had a lifetime higher than 225 months. Well, if we look at that, how many had a lifetime, how many total had a lifetime higher than 225 months? 2. Okay, so here's what you got to do, okay, to give a percentage. I'm writing on the wrong screen here. You need to take 2 out of the 16. Divide that. You'll get a decimal. What do you get? You get 0.125. Move that decimal 2 places. That equals 12.5%. Okay. Divide the fraction. Look, the top number was how many fit that requirement. Okay, that was our what's the word I'm looking for? That was our favorable outcome. Okay, we're looking at 2 out of the 16 made it past 225 months. Okay, then you got to go further and make it into a percentage. Good, thumbs up. All right, okay. All right. I'm having too much fun with this. All right, sorry. All right, next question. Shape of the distribution. What is it? Skewed right. Okay. Remember that curve? I'm hoping this picks this up. You got the curve there. Boom. Okay. Most of your data is in this area here. Now, if it was normal, it'd be a perfect bell-shaped symmetric curve. But in this case, it is not. This ties into question E. Question E says, would you expect the mean, and I promise you, I've seen this type of question before, would you expect the mean to be smaller, larger, or approximately equal to the median? Larger. Skewed right. We just talked about that in the box plot in the previous question. Skewed right. We can expect the mean to be larger than our median. Okay? And part F. Okay? This is my favorite question of all time. Why? Because if you can answer it, you're starting to understand describing data, descriptive statistics. What measure of center and spread would be most appropriate? Not favorable, but appropriate, unbiased. Median as a measure of center. IQR as a measure of spread. Well, guys, I think starting to talk like a buddy of mine. I think I want to stop it right here, and we will continue on tomorrow.